Yeah, thank you once again for GCCA India to invite us, Pan United, to share our low carbon concrete with CO2 mineralization. I'm terribly excited and very honored to be able to share our low carbon solutions with everyone here. So Pan United, about something about Pan United. So Pan United, we are a homegrown ready-mix concrete and cement company listed in Singapore Stock Exchange. So our vision is actually to be a technology company in the concrete and logistics space. And our mission essentially is to shape smart cities for tomorrow. And a quick overview, beg your pardon, of our integrated, vertically integrated operations. Okay, Singapore is a land scarce and a small country. Also, we don't have much resources when it comes to ready-mix concrete. So all the materials that we use to produce concrete are actually imported. So as you can see from the screen, we actually own and operate cement storage facilities in Singapore. We also own and operate GGBFS or green cement factory plant in Malaysia. In Indonesia, we also operate and we run a quarry, and all these materials are being delivered back to Singapore. So in Singapore, we have our concrete business as well as in Vietnam and Malaysia. So and also, I think this is something quite that you guys are very familiar with, which is the whole life carbon of this life cycle of a building. So essentially, there are three parts. You know, when we talk about the whole life carbon, we have the upfront carbon, we have the operational carbon, and the end of life carbon. What I would really want to stress and to highlight is that for upfront carbon is primarily responsible for 50% of the entire carbon footprint of new construction. Now, why is this so important? Upfront carbon, basically this carbon that has emitted even before the start of a building that operates. So when we talk about operational carbon, yes, we can in fact put in new technologies, new chillers, efficiency, better efficiency chillers, energy savings, lights and all that, which can essentially reduce the operational carbon. But when we talk about upfront carbon, if it's not carefully planned and decide and to determine what kind of low carbon materials are being used in the buildings, this will be with the building until the end of life, until the building is being demolished. That's why it's very important to really look at the upfront carbon even before the planning, even during the planning stage. You know, I think whoever the consultant really get to really look at this carefully when they decide what kind of materials and they got to really choose select those low carbon materials in their buildings. And over on the global front, it's reported that between 4 to 5 billion tons of concrete are produced globally every year. And as the world's population approaches 10 billion, the global building stock is expected to double in size by 2050. So again, if the embodied or upfront carbon of buildings are not carefully managed and planned for, the carbon that will be emitted by this, will be of an enormous value. And that's why it's so important for us to really look at and how can we actually reduce the upfront carbon. So Pan United would like to share with you, our latest addition to our PanU Green Concrete, which is the PanU Carboncure Concrete. Now, first I shall share exactly who is Carboncure. So Carboncure is a clean tech company based in Canada. Its founder is Mr. Robert Naven. He's a founder and CEO. And their mission is to really reduce 500 megatons of global CO2 emission annually. And just a quick overview of some of the investors of Carboncure. And Carboncure is also invested by Breakthrough Energy Ventures, Breakthrough Energy Ventures is a $1 billion clean tech fund, and is actually led by Bill Gates, and among some of the world business leaders like Jack Ma and Jeff Bezos. Now on this map, what you can see are the installations or the batching plants that are currently using Carboncure technology. Majority are in US, Latin America, and in Singapore, Pan United, we are the first and only ready-mix producers to use this technology. And currently, we have already supplied this Carboncure concrete to commercially to some of the projects that uses Carboncure concrete for structure use.
Carboncure is clean technology that allows ready-mix concrete producers to reduce costs, deliver greener concrete, and win more business. Carboncure works by injecting recycled carbon dioxide, CO2, into fresh concrete during mixing. Once injected, the CO2 undergoes a chemical reaction where it transforms into a mineral, improving the compressive strength of the concrete, which then enables the reduction of cement content in mix designs while maintaining strength requirements. The Carboncure technology is made up of two boxes: the control box, which is the brains of the operation, and the valve box. The valve box connects to a CO2 tank and delivers a metered quantity of CO2 into the concrete mix. The CO2 is stored on-site in a pressurized tank provided by industrial gas companies. The control box monitors the performance of the valve box system in real time and feeds back all usage data to the Carboncure command center. The control box software integrates seamlessly with all existing batching software, so adding CO2 into a mix is just like adding an admixture, meaning no impact on batching or loading cycle time. Transfer hoses deliver liquid CO2 from the supply tank to the Carboncure valve box, which is at the plant loading area. The valve box then meters and delivers a known amount of CO2 into the concrete mix based on the cement content of the mix. The CO2 automatically injects into the mix once roughly half the cement and water contents have been discharged. While liquid CO2 is stored in the tank on site, the CO2 that comes into contact with the concrete is actually in a solid and gaseous state, similar to dry ice or snow. It changes state once it leaves the Carboncure valve box due to a significant drop in pressure. Upon contact with the mix, the CO2 undergoes a chemical reaction and converts into a mineral, calcium carbonate, which makes the concrete stronger. Plus, what was once CO2 is now eliminated, never to be re-released into the atmosphere, even if the concrete structure is demolished. Concrete made with Carboncure has no differentiating factor from concrete without CO2 in it. Fresh and hardened properties are not affected. Any mix design can be adjusted to include an optimized dose of CO2 and a reduction of cement content without compromising the concrete strength. This means Carboncure mixes can be used for all commercial and residential applications. Every cubic meter of concrete produced with the Carboncure technology saves an average of 17 kilograms of CO2 emissions from entering the atmosphere. An average high-rise building built with Carboncure would save approximately 680,000 kilograms of CO2 emissions, which is equivalent to the carbon absorbed by 360 hectares of forest in a year. Reduced cement content means reduced costs and a reduced carbon footprint, and more business from the green building markets. With Carboncure, concrete producers can create a legacy of sustainability in their communities while attracting and retaining employees who want to work for an employer that does something positive for the environment. Technology costs are offset by cement savings, one-day installation of the technology without disrupting operations. The technology can be retrofitted onto any wet or dry batch ready-mix plant. Seamless integration with your existing batching software means it's as easy to install as it is to use, all provided with the ongoing guidance and support of a dedicated Carboncure technical services team member. Join the growing network of concrete producers who are using Carboncure in hundreds of ready-mix plants around the world. It's simply better concrete.
Now let us take a closer look. So from the video, in short, basically when you inject liquid CO2 during the concrete production, essentially this CO2 reacts with the calcium ions from cement, and it actually chemically converted into a nano-sized calcium carbonate mineral, and is become permanently embedded in the concrete. And why do I really stress this permanently embedded? That means that this CO2 in the concrete, and during the end of life of the building, when we demolish this building, the CO2 will not escape back to the atmosphere. So from this slide, you can see the scanning electron microscope. 30 seconds after the CO2 has been mixed with cement paste, the red color arrow shows the nano calcium carbonate being formed. And this actually acts as a nucleation site for the hydration process. Ultimately, what do we have? We are having is able to give the concrete strength to make the concrete strength become stronger, or to rather to increase the compressive strength of the concrete. And what does it mean for ready-mix producers like us? We see this as an excellent opportunity to reduce the upfront carbon of concrete in this manner. And we can actually, by reduce cement, to lower the cement, to lower the embodied carbon. Now, when we look at the batching system, these are some of the photos taken from our batching plant. The batching software can be seamlessly integrated with the Carboncure technology, and it can actually helps to, in fact, the liquefied CO2 is being injected in the central mixer, and the valve box will actually inject a precise dose of CO2 into the concrete. Now, let us take a closer look at the carbon footprint reduction that we have for PEN-U green concrete. Mix 1, typically we have 100% OPC concrete with no recycled materials, no green cement whatsoever. So for typical grade 40 concrete, the carbon footprint we are looking at is about 492. And between mix 2 to mix 7, we have different types of green materials added, and to replace these green, to replace these natural aggregates and even the ordinary Portland cement. So we are able to reduce the embodied carbon, upfront carbon, by as much as 48.7%. Now, when we introduce this Carboncure concrete, we are able to achieve a breakthrough in achieving more than half, which is 52.8 to be exact, of CO2 reduction. So whatever recycled materials that we use to replace, and we put in Carboncure concrete, and we put in the CO2, we are able to further reduce the cement in the concrete. Now look at a scenario play out for Singapore concrete production numbers. On the left, when you look at the cement reduction, essentially we are reducing between 15 to 20 kilogram of CO2 per cubic meter. And how much is being sequestrated is 0.6 to 0.8 kg. So altogether, when you talk about 14 million to 16 million concrete production a year in Singapore pre-COVID, potential reduction and avoided of CO2, we are looking at 225,000 tons of CO2. Now, all this would not be possible if not for Pan United approach, to a circular economy. So I will quickly bring us through what do I mean by Pan United circular economy. So when we talk about the circular economy during the concrete production, from the start, we have all the materials that go into concrete. We have things like natural aggregates, cement, your admixture, and water, and so on and so forth. Then we start to ask ourselves, what is the one component or one material that has the highest footprint, or that contribute to the highest, largest carbon footprint of a concrete? So obviously the cement, ordinary Portland cement, is the largest contributor. So by focusing and zooming in on cement, we start to ask ourselves, how can we actually replace this with other alternative, like for example GGBFS, which typically has about lower than 10% of carbon footprint with that of ordinary Portland cement. And next, we also ask ourselves, can we actually further reduce this cement? And in Pan United Carboncure concrete, by injecting CO2 in the concrete, we are able to reduce the cement. Thus, we are able to further reduce the upfront carbon footprint in these concrete products. And very quickly, when we talk about the byproducts during the concrete production, we admit the different types of waste material like sludge, and we also produce grey water. So Pan United, we actually look at how can we upcycle some of the waste like this sludge into a product. So we have successfully recycled and upcycle our sludge into a product. We call it liquefied soil stabilizer in Singapore, and it's being used for filling up of abandoned pipes and for slope stabilizing. And through our concrete design, our team of material scientists and concrete engineers, we are able to produce over 100 concrete products that fulfill the highest 4 tick status of the Singapore Green Building Product Listing Scheme. And talking about digital process, which also forms a very important part in our circular economy. And through the digital process, we are able to incorporate sustainable practices during our concrete production. So I will not go through everything. I will just pick up one or two. So one of it, which is our EDO. Every drivers, mixer truck drivers of Pan United, currently we are not having the manual DO. Instead, they are carrying iPad. They are carrying a tablet that replaces the manual DO, which gives our customers a lot of convenience, and we are able to save about 13 tons of paper annually. And our air digital system, which stands for artificial intelligence in ready-mix concrete, also helps to reduce carbon emission by through truck optimization, and also we are able to manage and through our command center the supply of raw materials right from the start to the concrete delivery to our customers. And I especially want to highlight our in-transit concrete management system that I shall start over here. So in the past, concrete mixer trucks, after being loaded with concrete, when it leaves our plant, there is no control in terms of the quality anymore. And usually in Singapore condition, the traffic is very heavy especially during peak hours. So mixer trucks tends to be caught in a jam, and concrete will lose the workability. And furthermore, this does not help when the mixer truck reaches the customer sites, and we have site conditions that is so unpredictable. Example like the concrete bump breakdowns and all that. So when the concrete loses the workability, it faces a situation where the concrete may be rejected when it's time to be discharged. So with our artificial intelligence mixing system, it uses AI, artificial intelligence, and machine learning capabilities. And this system is actually attached to the mixer truck itself and is able to manage, monitor, and also measure the workability, concrete workability during transit. So just like I mentioned about the problems that we face when the moment our concrete mixer truck leaves the batching plant. So when in this time round, when the mixer truck are being equipped with the AIM system, the machine learning starts to take place and start to measure the workability, and it will enable the water addition or admixture addition to the concrete in the mixer truck during transit up to the point when it discharged, so as to achieve target to achieve zero wastages by rejection and also 100% acceptance. So a snapshot of the benefits of our artificial intelligence mixing, right? When we are able to use even when we talk about sustainability, we are able to use less cement for our mixers and less fuel consumption from our mixer trucks, and we are able to also to reduce concrete waste. So these together with our Carboncure and also our air digital system, AIM digital system, we are in fact sharing, or we are actually marketing this technology to other ready mix in this region. So to come back, our circular economy, just to recap and just to close the loop, we are talking about the waste minimization, where we actually recycle this concrete waste that is returned by our customers into recycled concrete aggregates to be put into our green concrete.
Yes.
So coming to my last few slides. So right now we really want to call upon call to action for the groups of regulators, investors, developers, even manufacturers like us, to really to look very very seriously into reducing upfront carbon. We believe that every one of us have a role to play. When we talk about even the regulators, we are seeing very good examples from India, to even to reduce the emission intensity, by 33 to 35% by 2030. And even we have states like in Canada, the Calgary International Airport, they are also legislating the injection of CO2 in concrete for their projects. And when we talk about investors, people like Microsoft, LinkedIn, they have also made very bold commitment. And I believe that they will be also looking at buildings where it's more greener, to even to have their offices in, or even to build their data centers or to warehouse. Right. So last but not least, even for manufacturers, I think we also have a choice we have a goal to role to play, and to really to enable ourselves to provide these low carbon solutions. So in short, there is no planet B, and I think I'm running out of time, and just want to urge everyone that to hop on this journey to reduce our embodied carbon. And I think I shall leave this slide. I think you are more than welcome to have any interested conversation with us, right? Any parties, please feel free to contact us, and I think we are obligated and are happy to share our experiences with you, and we also want to learn from you guys. Thank you very much.